Hello, my name is Kedar Pavgi, the Hacks Program Manager for the National Security Innovation Network. NSIN is a Department of Defense program office tasked with connecting students and startups with folks across the department in order to solve national security challenges. I'd like to welcome you to NSIN's first hackathon of 2021, titled Mad Hacks Theory Code. Normally, we'd run these events in person to work on challenges like the one we're asking you to help us solve over the next couple of weeks. Unfortunately, the ongoing COVID-19 pandemic has made it impossible to hold hackathons in person. That being said, the problem sets remain the same, so we're taking our hackathons virtually to make sure we're doing our part to meet the needs of the mission. We're excited to host Mad Hacks Fury Code alongside our partners in the Army, including the 1st Cavalry Division, Combat Capabilities Development Command Ground Vehicle System Center, and the Next Generation Combat Vehicles Cross-Functional Team. We're also excited to partner with a few universities across the country, including the University of California, Berkeley, the University of Washington, San Diego State University, and Georgia Tech. Finally, we're also excited to partner with Dell Computers as a part of this iteration. Before we get started, here are some key dates for this hackathon. This hackathon begins on February 5th, 2021. You have until 11:59 p.m. Pacific time on February 19th to submit your solution to the problem. On February 20th, we'll select 8 to 10 teams to take part in a pitch competition on February 26th. This will be in front of a VIP judging panel. Think top government executives, venture capitalists, and subject matter experts. Between then, you'll be able to engage with mentors representing end users experiencing the challenge firsthand and technical experts who can help you conceptualize your solution and check your work. What we need you to do is to take the time to talk to the mentors and do the deep customer discovery necessary to understand and solve their problem. We're also going to ask you to engage with the other participants, bounce ideas around, and form teams. You're welcome and encouraged to come with your own team already assembled, but we find that diversity is the key to the best solutions. You shouldn't be afraid to find other people who complement the skills and experience you and your team already have. Our challenge is hosted on the Defense Innovation Network website, located at the URL you see here. This website will have all the resources you need, including details on submitting a solution and resources to get you smart on the problem. We also have a Discord server where we'll be posting updates and other information about this hackathon. If you have any trouble accessing any of the resources, please let me know, and I'll be happy to assist you. So, what are you all competing for? Well, we have a $70,000 contract pot from which we'll award the top teams funding to continue developing their ideas, alongside our subject matter experts and end users. There may be other opportunities that open up for teams as part of this hackathon, and we encourage you to interact with the mentors and evaluators as a part of this process. You're definitely not expected to have a working prototype by February 19th. Rather, what we're looking for are novel, yet technically feasible concepts for solving the challenge. Lastly, I want to present you the challenge that you'll all be thinking about over the next couple of weeks. I want you to keep this challenge top of mind as you begin thinking about your potential solutions. This challenge may not mean much to you right now, but it will after you've had a chance to dig in and really dig deep. We're looking for you to develop concepts, technologies, or systems to help human-controlled and autonomous vehicles operate through cyber attacks or other instances of electronic warfare, and return to a good known state with or without human intervention. With that, I'd like to pass it off to my colleagues in the Army to walk you through an example scenario.
Hello, everybody. My name is Major Mitchell Sanick with the 1st Cavalry Division. I'll be presenting your example scenario to give you an idea of how the challenge Kedar mentioned earlier could affect all of us serving in the 1st Cav in the near future. Imagine this. It's the year 2030 and a major natural disaster has stricken a friendly country. The affected nation, a longtime ally, has requested U.S. military assistance to aid in their recovery. U.S. Army forces, including elements of 1st Cavalry Division, are called up. The host nation is undergoing political unrest. Prior to the disaster, separatist groups have begun disrupting the central government and have attacked key public infrastructure and military facilities. Unfortunately, a large portion of the population impacted by the natural disaster lives within the territory that is controlled by the separatist group. The primary objective of response teams is to deliver medical supplies, food and water to the afflicted population. Given the political instabilities, a convoy consisting of 1st Cavalry soldiers is assembled to accomplish the mission, while providing protection for the U.S. and host nation personnel from potential separatist attacks. The convoy consists of supply trucks, personnel carriers, and a handful of their recently fielded, operationally manned fighting vehicles, or OMFVs. Each of these vehicles supports autonomous and semi-autonomous operating modes, meaning they can work with or without human directly in control. The vehicles are designed to protect from many forms of cyber attack, a known separatist capability. However, it's possible that there are vulnerabilities built in. The components supporting these vehicles all rely on commercial protocols and communication standards, such as Controller Area Network, or CAN, and Vehicle-to-Vehicle, or V2V, which offer little to no communication security. The use of both wired and wireless communication also poses additional risk when in close proximity to adversarial forces. First Cav will need your help to operate safely within the contested environment and successfully complete its mission. Here are some questions to get you all thinking. If the separatists use a cyber attack to take advantage of the system, how would the operators know that it is compromised? What is the next step if the system is compromised? How do we ensure that the mission continues without the vehicular systems being turned on one another? Is there a way to return the vehicle to its quote-unquote factory state while still operating? Are there redundancies that could be built in to help personnel keep the mission on track? How would you regain control of a compromised vehicle if there is limited connectivity? With that, I want to pass it to my colleagues to give you more details on the focus areas for this hackathon.
My name is Phil Smith from the Combat Capabilities Development Command, Ground Vehicle Systems Center. I want to walk you all through the 3 focus areas of this challenge: resiliency, situational awareness, sustainment and recovery. We'll start with resiliency. The goal here is to have a system that includes a monitoring and recovery agent, but can also be trusted to report its status correctly. The goal is to have a secure and safe system that will have some sort of error detection, which triggers a deterministic response for each independent subsystem. The method of error detection and response can vary, but will ultimately rely on a flexible, solid, and reliable supporting structure. Some aspects to consider here: resource availability and access, real-time support, system modularity, and support for a wide array of possible error detection. For example, fusing multiple algorithm and sensor outputs, leveraging algorithm transparency information, etc. And recovery. For example, is there a way to rotate in a clean copy of the system, rolling back the system to its original state, or other approaches in the middle of a mission? Second is the situational awareness piece. To best understand this, assume that Army vehicles are operating in a low infrastructure environment. In the scenario Major Sanik outlined above, it's in a foreign country following a natural disaster. Commanders will have limited knowledge of nearby forces through Blue Force tracking, which essentially uses GPS technology as a backbone. Team members will know Army procedures, but may not know how their fellow soldiers are executing those procedures as part of the mission. The goal here is to think about how vehicles operating autonomously will have potential contingency plans and taskings associated should they be compromised. Are there ways to identify damage, defects, or irregularities, or pass off information to fellow teammates? Could that information be communicated safely and securely? Lastly is the portion on sustainment and recovery. A military vehicle isn't like a normal piece of technology. Just because some of these platforms will operate without human control doesn't mean it'll be like Siri or Alexa powering these vehicles. But these systems are supposed to be reconfigurable. So what does something like updating a Wi-Fi driver or resetting the network adapter look like for an autonomous system in the field? Tough problem. For example, the system is running on Linux or another operating system. There are clearly user, super user, and admin variations that allow certain operations. Expand that concept to the autonomous vehicles. What actions should be defined at the behavior level? What about the vehicle management level or the interface level? For example, enabling, disabling, or configuring convoying behavior might be user level, but teleoperations might be a vehicle management level. Then the interaction between the different pieces of hardware might be at the interface level. More likely than not, there's a solution that cross-cuts the different aspects or viewpoints of the system. We're looking forward to seeing your thoughts here. Reach out to us if you have any questions, and good luck.